But we have our super exciting panel that we have to get to actually right now regarding getting creative with 3D printing, with who the moderator will be Ankita Joshi, autonomous vehicle safety engineer from General Motors, Daniella Morris, who's an additive manufacturing engineer at SpaceX, Anna Chase, who's a technology innovation engineer at Lego, Celina Gratton, project manager at Airbus, and Mary Hadley, who's the CEO of MakerGirl. So if all the participants could please turn on their cameras. I believe, Mary, I still need to give you access to do so. But let's see here. Everyone else, you should be able to join me on stage. Let's see. Just making sure that helps. So Ankita, Celina, Daniella, Anna. Here you go. Sorry, need to give you permission. All right, and Anna, you should be good to join us on stage. You want to turn on your camera? Perfect. Awesome. Well, without further ado, I'll let you all get started.
Okay, well, can everybody hear me? Thumbs up. Okay, awesome, great. Well, first of all, for all of our listeners, hope you all are having a very fun couple of days at the conference. And I'm also just coming from Virginia's presentation, and yeah, the jewelry was beautiful. And now we have an incredible panel here who's going to talk about how they use 3D printing in all the different fields that they're a part of. So let's get started. Again, we're at the panel, and the panel's conversation topic is getting creative with 3D printing. First of all, let me invite all of our panelists. Firstly, welcome Celina. Celina is a graduate from McGill University in Montreal. She studied material science engineering and started her additive manufacturing journey at the Monash Center of Additive Manufacturing, where she worked on metallic aerospace parts. From there, she joined additive manufacturing team at Airbus, and she currently works as a product manager there. Welcome, Celina.
Thank you.
Next, we have Anna. She is a design engineer at the Lego Group. She also has an extensive background in product development and manufacturing. Previously, she worked as a plastic injection molding tool maker at Harbeck. And I think one of the coolest roles that she has had is being a lead product engineer for the Star Wars Black Series collector figures and vehicles. So hopefully we get to hear more about that. Welcome, Anna. Next, we have Daniella. She is also working on additive manufacturing at SpaceX. As a young child, from a very early age, she's been really passionate about exploring the space and actually, hopefully, even visiting the space one day. And her passion has really fueled her career. She has a degree in welding engineering and also has focused a lot on material science and process development. Hey, Daniella.
Thank you.
And finally, we have Mary. Mary is the CEO of MakerGirl. Her organization focuses on educating girls between ages 7 and 10 about STEM through 3D printing. Her organization has reached over 4,600 girls till date, which is incredible. Mary graduated from University of Illinois, Urbana-Champaign, and has a bachelor's degree in chemistry. Welcome, Mary.
Thank you.
So Mary, actually, my first question, let's start with you. I do want to talk to all of you about what you do at work, but my first question is directed to you. How were you introduced to 3D printing, and what about 3D printing really inspired you?
Yeah, so during the summer going into my junior year of undergrad, I joined MakerGirl as our lead for our second MakerGirl Goes Mobile truck tour. So I learned how to 3D print 1 week before I left to drive around the United States to teach over 500 girls about 3D printing. So I learned a lot along the way, as well as while I was teaching. But I was basically just super involved with getting really excited with maker spaces and libraries along the way, and watching every student just eyes light up when they got to see their 3D print come to life.
Okay, awesome. And I have the same question for, I think, everyone. Like, I know you all are coming from different industries and also from also working on different roles. But what was the first thing about 3D printing that attracted you? Daniella, let's go with you, and then Anna.
There we go. Put my mic on now. Yeah, so I was actually, as you mentioned, I was pursuing my degree in welding engineering, more focusing on the metallurgy materials process side. And I actually had already had an FDM printer that I just messed around with at my house in college, but I was specifically doing an internship at EWI in Columbus, Ohio, and I joined what I would now consider a small 3D printing development lab, and there I was able to work with several different materials. It was mostly metals and a laser powder bed. And actually got to be a part of that while they were building up their lab and making their own machines and everything. So that I remember it felt as though I was discovering the future, because most people that I would talk to about this hadn't really didn't know like where we were at in the industry with this. So being a part of that, I was hooked immediately. And I know that my next journey was at SpaceX, where I first was actually in the materials team, but I got to work with the additive team in that process. And again, I knew like once I got involved in additive that it was just something totally endless possibilities. So really excited to just be a part of that industry while it's building up.
Yeah, and then for me, my first touch point with 3D printing is when I was working as a project lead for the Star Wars toy collectible Black Series. So I would be working with these sculptors, and they were modeling these action figures. They were 3D modeling the action figures, and then they would print them on a 3D printer, the SLA. And the SLA is a super high resolution 3D printer. So once those action figures were printed, they would then go to China, where they were used to make the tool, the injection mold. That mold that would make like hundreds of thousands of these action figures. So that was the first touch point. And then later on, I worked at a manufacturing company using additive to produce a variety of designs, from aerospace and military to medical applications. And what was most inspiring about them is they would use designs from nature to help them design functions and features in their parts. So yeah, those are the big things that got me motivated about additive before I entered Lego.
Okay, awesome. Thanks, both of you. And I'm looking at the chat and I see that there were some issues with my audio. So before I kind of redirect the same question to Celina, I'm going to quickly ask the audience people to put in the chat. It's okay now. Oh, great. It's perfect. So Celina, I think we also dropped you, or we lost you there for a bit. The question that I was asking all of them was, what was it about 3D printing that initially grabbed your attention and sparked your interests?
Yeah. Sorry for the internet issues. It's been working fine all day. And then, of course, the minute I step into a panel. But yeah, so I studied materials engineering at McGill. And as part of my engineering program, I had to do compulsory internships. Growing up, I was always fascinated by aerospace. So I actually started my first internship in an aerospace industry. And I wanted to do my second one in a more academic field. So I sat down and I Googled top 50 aerospace universities in the world, and I started messaging professors on interesting projects. And I found this one project at the Monash Center of Additive Manufacturing at Monash University in Melbourne. And they were actually 3D printing light metals for aerospace applications. And I thought that sounded really cool. So I just started doing lots of research on additive manufacturing, on metal printing. And I emailed the professor and I got an opportunity to work with her for a semester. And then from then on, I thought aerospace and additive manufacturing was such an exciting combination and something I wanted to carry through further.
All of you come into 3D printing from a lot of different avenues. But I think one of the things that's kind of ties all of that is you had something to do with schooling and education with your first exposure to 3D printing. So I guess my natural next question goes to Mary, because I think with 3D printing, you're really working in the space of building the education pipeline. So can you tell us more about what exactly does MakerGirl do, and what is your role as a CEO?
Yeah, for sure. So MakerGirl, like you said, educates girls ages 7 to 10 through 3D printing workshops, and we do this through a couple different avenues. The first being MakerGirl Academies, which are groups of university students that host our 3D printing sessions at their local university and in the communities that surround them. Basically, they introduce what 3D printing is, how it's being applied in so many different fields out for their lives. So our pre-COVID session was about 2 hours in length, and by the end of it, each MakerGirl walked home with their own 3D design. Now we also do our virtual curriculum, which launched in June, and we are live on Zoom with our students, and we are able to kind of do a modified version of that, and then we print out all of their designs and mail them home. Our third avenue is MakerGirl Goes Mobile, which I touched on a little bit before, which is a summer truck tour where we basically pack up 15 3D printers and drive them around the United States. We really try to focus on different rural communities that maybe don't have access to the same 3D printers as other spaces as well. And we really focused on 3D printing to improve girls' spatial skills, which is an early indicator of later achievement in mathematics. And we also separate ourselves from other organizations doing similar work in STEM education by, like I said, focusing on 3D printing because it allows girls to both be analytical and creative. My role as CEO is really focusing on working on the future programs and kind of giving students a next step in their STEM journey, as well as focusing on our partnerships with different sponsors or corporate or community. And we are excited to launch our next curriculum later in February. So super excited about that and kind of continuing to open up MakerGirl Academies at different universities.
I mean, just by hearing what you said about MakerGirl, I can't imagine how meaningful and impactful your work is. And we'd love to learn more about what your girls do later on this panel. But, I mean, yeah, I think 3D printing is a great technology that is enabling girls and kids to look at their potential in STEM. For me, personally, growing up, I think what drew my interest in engineering was Legos. So, my next question is directed to Anna. So yeah, Legos, I feel like that was all of our favorite pastime growing up. So is working at Lego actually as fun as actually playing with them?
Yeah, I would argue to say it's more fun than playing with them. And, at Lego, if I wanted to sit at home and make a Lego set, I could do that. But if I was like a piece had fallen to the ground and I lost it, then I could go into this building with this huge library of elements in all of the different colors and just pull the one I needed. But working at Lego, I have the full database of all of the elements, so it can actually go in and download it and make an adaptation to an element and then add it to my set. Yeah, and so it's an unreal experience to have all these resources at my fingertips.
What is your current role at the Lego Group, and how do you use 3D printing in your current job or your previous jobs?
Sure. Yeah. So at Lego, my role kind of consists of 3 parts. First, I'm responsible for designing and researching new functional features for AM elements, and also design leads across Lego on how to design for additive manufacturing, 3D printing. Third, I conduct experiments to further understand the capabilities of the Lego Group's additive manufacturing machines. So how this, applies to what my relationship is with 3D printing, literally, I'm looking at a full life cycle of an AM Lego element from concept to final part and all of the troubleshooting that goes through that process. Yeah, so really a lot of touch points.
Yeah, I can't imagine how much fun that might be to actually see, be at the backgrounds of something that like a product that's so near and dear to everyone's hearts. I think another curiosity, I think just talking about complexity about things, and so now my next question is for Daniella. You work at SpaceX working on, I think, some of the most complex machines out there. I'm not sure how much of that you can really share with us, but I want to ask, like, how is 3D printing and its technology leveraged at a high level? And I guess not just in space, but even before, how have you leveraged 3D printing in the jobs and the works that you've done?
Can you hear me? Yep, clear. Yeah, so as you mentioned, I can't go into much detail. So currently I'm in the development area where we're working to develop laser powder bed platforms in order to develop and build rocket engines. So how to answer that without giving away details. So really in every aspect of, like, developing the engines, and leveraging my background with materials, and learning the new tools that I've learned as far as like design for additive and all of those features, it all really does tie in very heavily on that side. And even in my previous role, as I mentioned, I was a co-op for like a year or so at EWI. I was able to, again, like, look at, for instance, different infill basically for like specific materials that maybe we're wanting to change the strength, internal versus external. So really being able to run with any technical challenge at SpaceX has been really cool, because as this industry in itself is, the possibilities are endless. That's kind of the mentality at SpaceX as well. So it's leveraged pretty heavily, to answer.
Yeah, no, thanks for sharing everything that you could. I think just by what both you and Anna said, I think 3D printing really brings that trial and error and testing, sort of like that element which is so crucial for innovation. But I think other than just using 3D printing for creating a product, that's definitely the creative aspect of it, but you also need a lot of creativity to work the logistics behind, right? Getting the right printer, the right kind of materials for the right kind of testing. And I think, Celina, as a project manager at Airbus, I imagine that those might be some of the questions that you have to address, right? So what is your role like trying to get 3D printing and the technology access to different teams?
Yeah, so I find project management one of the most exciting roles in 3D printing, because you really get the whole end-to-end process of additive manufacturing. So first, my role includes choosing tools and ground support equipment that we sell to our customer that are traditionally manufactured that we could additively manufacture. So that is taking into account the design complexity of the part, the weight and the size of the part, the ordering volume. So you mentioned the logistics. So spare parts are ordered very sporadically. You never know what order is going to come in. So taking that into account with the additive manufacturing technology is a great benefit. And so working with engineers to try and modify these tools from a traditionally manufacturing tool to a 3D printed tool. I also work with the procurement department to look at what suppliers would fit well for us, awarding contracts, negotiating prices, and then finally with the customer aspect, so looking at the sales and how successful our tools are doing. So we work directly with our customers, with the marketing team, and with the sales team.
Yeah, thank you so much. I think that really gives an insight into the kinds of skills and the kinds of people that are contributing to making the 3D printing and additive manufacturing technology very, very accessible for everyone. I think all of you spoke a lot about your work, and I do want to go back to the theme of this panel, which is getting creative with 3D printing. So kind of looking back, whether it be your day-to-day jobs at work or maybe
your experiences with additive manufacturing back in school, or maybe teaching others or introducing others to 3D printing, what has been the most unique project that you've worked on? And what did you learn out of that, whether it be learning something about 3D printing or learning something about yourself? Because this question is directed to all of you, and so that we don't talk on each other, I'm just going to call out names. So let's start with Mary.
Yeah, so I think kind of one of the most unique parts that I've ever worked on was definitely, like I said, MakerGirl Goes Mobile. The road trip was just super unique because each day over 5 weeks, I had about 2 to 3 different sessions of about 25 to 30 students. So I would drive to a new location, pop up shop a 3D printing lab. So I would take 10 3D printers out of our van, set them all up, start to teach our different themes of the day, and get all of the 3D prints on those 10 3D printers and print them out in the 2-hour session. So I learned a lot about fixing printers quickly, but the biggest thing that I learned is how big the 3D printing community actually is, especially online. So either looking up what is my 3D printer doing right now and how do I fix it, and just finding so many discussions, different videos that I could watch. It was for someone that was entering like 3D printing for the first time. It was something that I didn't know was there, and definitely learned a lot about that, and being able to just interact with the 3D printers kind of 24/7 for 5 weeks was just one of the most unique experiences I've ever had.
Yeah, definitely. And I think I'd echo the fact that the 3D printing community is so close-knit and supportive. That's also been my experience very much. Yeah, I want to hear also from Daniella next.
Yeah, so I would definitely have to say, though, as you mentioned, I can't discuss much on this one, but I would have to say rocket engines are probably the most unique project I work on. But aside from like the specifics of like what I'm working on detailed at work right now, for instance, as I mentioned, I was involved in my undergrad as well with additive manufacturing. And this applies to everything that I do at SpaceX as well. But for a student team I was a part of, I was actually the VP, and we decided we wanted to use 3D printing for our rover team vehicle, which is basically a student competition team that we go and compete at NASA globally with several other student teams, high school, college, and students get together and they build rovers and they simulate a Mars terrain. It's really cool. So with my passion for space and additive, I wanted to figure out where we could do that. And I also, as you mentioned, with laser powder bed specifically, not everyone has the ability to just use a laser powder bed machine at their house to figure out how to use that to be ready for their career. So we actually worked with FDM printers to print the tires and worked with a bunch of different designs. And so that taught me so much, just understanding how quickly you can iterate when you're doing development with additive manufacturing. Anything you can think of and design and slice, you can make, which is not the case in most manufacturing options, especially like even welding. You have limitations in any way that you join things, but additive has just been totally different ballgame in that sense. So I would say rocket engine is definitely the most unique, but the rover team definitely learned the design process and the failure process over and over again until we figured out our design.
Mm-hmm. Yeah, definitely the learning curve at the end is definitely the most valuable aspect. Yeah, same question. What has been the most unique 3D printing project directed to Anna?
In general, learning more about the design limitations and constraints of the machines. And I also just learned a lot about product and quality tests that go into making a Lego element. For example, if I had the pogo stick, right? There's a product safety test where you're torquing it 360 degrees. And if in doing that, it breaks and forms a sharp point, then you have to design it so if it's under the same torque that it's not forming that sharp point. Like crazy stuff you wouldn't think of. And yeah, just in general, what I learned is how much work goes into making something so small and making it consistent over a batch of thousands. Yeah.
Yeah, no, I can imagine. I know I've heard a lot about how important quality control is for manufacturing in general, but more so also for Legos. So yeah, thanks for giving us that insight. And yeah, finally, Celina, what's been one of the unique projects that you've worked on?
Yeah, so this one's really cool. So I don't know if you guys remember, but back in the day on aircraft, when you had your entertainment system, you'd have your controller on the armrest of your seat. And so this one airline came to us because they upgraded with touchscreen entertainment systems. So they were left with a hole in their armrest. So they came to us for a solution on just a cover to cover up that hole. And obviously it was only a small batch size of parts that they needed. So it'd be too expensive to create a whole tooling system for a different kind of technology to manufacture these, for example, injection molding or whatever, for only a handful of parts. So we decided to go with 3D printing. So it was a quick and effective part that we printed, that we sold to the customer. They were happy. But the thing is, the passenger started playing with these covers and stealing them. So the client came back to us and asked us if we could modify it and make it more robust. And if you imagine if we would have gone with a traditionally manufactured technique, the cost, the non-recurring cost that would have gone into redesigning this part, remaking that entire tooling, that entire manufacturing process, it would have been so expensive, so time-consuming, probably not even worth it. But with 3D printing, the flexibility of the technology, you could just redesign it and print it, and then it's ready to go on the aircraft. And that could have been done for many iterations as well if the second iteration wasn't good enough. So that really showed me the use of 3D printing, the flexibility of it, especially for small batch sizes and designs that you think you'd have to redesign in the future as well.
Right. I think the rapid prototyping aspect of 3D printing is definitely a huge value add for certain applications. I do want to follow up with you, Celina. Kind of keeping in mind where the technology of 3D printing is headed. Thinking more about it from a technical perspective, what about the future of 3D printing are you excited about? Like, what do you think looking forward, there are going to be some changes that are really going to add and multiply the creativity aspect or the way people can get creative with 3D printing?
Yeah, so I believe the technology is pretty much there for aerospace. The only thing with it though is the certification is just, you need to go through extensive testing and expensive testing and certification processes in order to get those parts safe and 200% safe and ready to fly. So the technology is pretty much there, especially the light and strong metals. Obviously in aerospace, the lighter your parts are, the less fuel you burn, so less emissions and cheaper cost of fuel as well. So light and strong metals are always a positive. But also something coming in the future would really be the integration of complex parts. So sometimes you could have a very complex part that's made up of 10 or 15 parts that requires welding and just different sort of attachment processes. Whereas with additive manufacturing, you could just build that part in one go, and that saves so much time and money in the manufacturing process, and weight as well of the part. And then when it comes to the spare parts business, which is where I was more focused on, it's also, I was saying, the uncertainty of when a part will be ordered. So for example, if it's an old aircraft that comes with a damaged part, and let's say the supplier of that specific part went bankrupt, or they don't manufacture that part anymore, just the ability to be able to 3D print it on the spot just saves so much time and money for the customer.
Yeah, and I think that thanks for giving that insight about the future and what the future of 3D printing can bring to the aerospace industry. And I have a similar question for both Anna and Daniella. which is when you look at, the future of 3D printing and where it's headed, what aspects about it are you most excited about and that you're eagerly waiting for? Anna, let's start with you.
Sure. Yeah. So I'm really excited about multi-material 3D printing, especially just from parts I've seen. There can be features hidden in a part that you activate and you just would have never anticipated the kind of function it creates. So for example, like MIT Media Lab released this ladder, and at every joint of that ladder was a soft material. And then at every like spoke or every bar in the ladder was a rigid material. And when they activated the ladder from one side, it actually curved up, if you can picture that. And that is just like magical to me. And I've seen similar parts of that, and it's like those types of technologies that really get me excited. So something I'm like eagerly awaiting is a machine that, so currently the machines I've seen that can produce multi-material parts have a resin that's like toxic for Lego standards. And so for a machine that can use a non-toxic material, yeah.
Legos.
Yeah.
Daniella, what are you excited about?
Yeah, not just necessarily for aerospace, but just in general, I think like emerging hybrid processes, as she mentioned, really excited about also like multi-material. Definitely just, I think like right now, this is so new that we are making additive work for the way that things used to be done. But as the years continue to go on, we will be actually realizing capabilities that we have to start from different starting points because we don't have the same limitations. So like new approaches to development, rather than, like using the materials we have, designing materials for printing, rather than using, sorry, I had something written down. Rather than basically just like using what we have now, but actually tailoring the tools that we have to additive manufacturing, like instead of just kind of using additive manufacturing to bridge the gap in some areas. And then I'm also extremely excited about like printing in space. For instance, which this is public, I'm sure. The space station basically doing like biological 3D printing, just being able to be a part of like the mission setting that and stuff is just, I can't wait to see like what this does for the medical world too. And overall, just the speed and improving these processes to the point where there isn't a sector that like can't find value in additive manufacturing. I feel like even as I started in additive as interning in 2017, and it's just insane how much has come up even since then, before I even graduated, for a couple of years there. So really just looking forward to see even like a year or two from now, what else is coming out.
Yeah, definitely. It's very much a fast-paced area, and there's so much that's already happened, and definitely a lot that is to happen. And we're, I think, very much in the flux of the space. And I think that's what exciting is. It's also the new people who are going to come into the space of 3D printing, who are going to be the leaders in taking a lot of these innovations a step forward and kind of expanding the horizons of the creativity. And I think, so Mary, you are working in the space of education. So I have a slightly different question for you, also looking into the future of 3D printing, but more with the lens of education. Like when you look at the role 3D printing has played in education so far, what is your vision and what is your hope that, what role would 3D printing or what should it play in the sectors of education, K through 12 or otherwise?
Yeah, I think I'm really excited for just like the access that students will have for future generations to 3D printing and being exposed at an earlier age. For me, like I said, I only learned how to 3D print towards later half of college, but I know when we've gone into different classrooms, they have started to have 3D printers in their libraries or in just like their STEM rooms. So it's been really exciting, even over the 3 years that I've been with MakerGirl, to see how we used to go into classrooms and it might be their first time or exposure to 3D printing. But now we go back to those classrooms and they say, like, we wrote a grant to get this 3D printer, and now we're excited to show all our friends how to use it once you leave. So I think just that continued access to 3D printers for teachers to add to their curriculums, and I think just kind of also being able to have those in spaces that maybe didn't have them before, whether it's a local library or a classroom as well, just for that K through 12 exposure at such a young age is just what I'm very excited for. And I think in education, teachers will start to be able to loop that into younger curriculum, or for student projects, like if they're looking around their classroom and they don't have something to add to their like school project, they could just go print it. So that's what I'm really excited about as well.
It does sound exciting. There were a lot of questions that I had on my list, but because of the interest of time and because of the number of audience questions that are flooding in, let's move to audience questions right away. The first question that I have, it's directed mainly for all of you working at companies. Like, how has the supply chain been affected due to COVID? And how have you changed or increased or reduced 3D printing because of that?
I can go. COVID's actually been something that's helped Lego because everyone's inside, and so a lot more people are playing Lego than usual. But as far as AM's concerned, like everything we have for production has maintained the same agenda since before COVID. Yeah.
Celina or Danielle, can you add? Do you have anything to add to that answer?
Well, personally, in Airbus, a lot of the R&T projects have slowed down a little bit due to COVID, just because it's like the more explorative side of things. However, we did put our printers to good use to print PPE and to deliver that around the world.
Yeah, awesome.
There were a few months there where things slowed. I think the world was adjusting together while the supply chain was also adjusting, but overall it hasn't hindered development or anything like noticeably. So like she mentioned, we're still on track for most things that were going on before COVID.